more sense when it comes to what I mean, or what mathematicians mean when we say polynomials. But we're doing these Desmos activities. Now, to help us get further into these ideas, so what we're trying to be able to do is sketch polynomials when given the graphs of their factors. And so, as a reminder, like, this is a function. Hopefully, we recognize the factors in these equations, or in this equation. What's one of my factors in this equation? So x plus 3 is a factor. What else? X squared minus 4 is a factor. And what we want to be able to do is we want to be able to use those factors to actually sketch what the function f of x looks like. And that's what this Desmos activity is all about, helping us understand how to sketch f of x based on just those two factors. And because when we learn this well, we're going to be able to extend it into stuff like this. And even more beyond this, okay? And so we're trying to use this Desmos activity to figure out all of these ideas. And we'll come back to this later. And this is more about the next set, so I'll talk more about this later there. But what I want us to do to help us get better, reestablish what we did last Friday, what we have is a function h of x is constructed by taking y equals 2x minus 3 and dilating it by x plus 2 as shown in the graph. So if you look at the graph, or the what I sent out on the calculator, there is already a 2x minus 3 graph there, correct? Yep. And then what we're going to do to that 2x minus 3 is we're going to dilate it by x plus 2. And all I'm simply asking is, take a few minutes and figure out what you know about h of x. Sorry, you can't see that. So just write any conjectures you have. What is h of x? What do we know about h of x based on these two factors? So just a couple minutes. We all go with that? Just like anything we know about h of x. Todd, you look like you're confused. Yeah, so f3 of x is the 2x minus 3, right? Yeah. Let me remind you of this really quickly, actually. No, that's not what you want to see. When I say that word dilate, what does that mean? Stretch or compress. Now, kind of, right? If I take 2x minus 3 and then I dilate it by 4, I'm multiplying by 4, I'm making it bigger, right? Bigger or smaller. But remember, we said it was going to be a little bit different when we dilate by a variable like this. There is one thing that's still going to stay the same. What's a key word that we want to keep in mind when we say dilate? Transformation. It is a transformation, but what operation went with that transformation?
Operation.
Say it again. Remember how I multiplied by 4 earlier? When we dilate, we're still multiplying, okay? But in this case, what am I multiplying this 2x minus 3 by? The x plus 2, right? We're taking this original function and we're dilating it by that x plus 2. Okay, so that x plus 2 that is in the graph. And so I just want you to come up with anything that you remember about h of x based on our conversations. Okay, so let's just go to the boards, come up with any 2 or 3 ideas, just something to generate some ideas. We'll talk about it in just a second. So actually, y'all can talk about it in your groups. You don't have to write on the boards. We'll have a conversation in a second. So let's say 2 minutes. Come up with any conjectures that you remember based on these graphs that I sent to you. It helps when that's tops on so that it actually comes through. So if you look at Chelsea, what happened to your equation?
What are they?
You don't know? That's why you ask questions.
Oh,
But I know what I'm talking about.
Okay.
Same
Give us a thing. I need to do things and not do
So
something.
look at all the graphs.
Good.
No, the last one is this one. And I gave you one. Did I not?
She said she don't know what you're talking about.
It's okay. Come up with something. Y'all are a group of 3. Come up with any ideas.
We all don't know.
So I've got this graph here, right? I've got y equals 2x minus 3, and I'm dilating it by y equals x plus 2.
You ready for cricket?
what do you know
Yeah, go ahead,
about
take off
h
work.
of x, the function that results by dilating those two functions?
Look, who get homework?
Huh?
Who get homework?
Did you get homework?
Can we get homework?
Yeah, it's called check your understanding questions.
No, it's paperwork.
No. No, what's the point of homework?
More brains.
No.
More brains.
Thank you. The point of homework is to help you grow and learn, not, and like, I'm gonna see that on your assessments. I'm not gonna give you homework grade for just trying to do something. I want you to learn.
That would be
So I'm
bad
gonna
on
assess
the, that would be bad on them because you forget this one.
You make the choice not to do it. Do you or check your understanding? And some of us have lots of homework. Football or whatever, and it's hard to do homework.
Welcome back to no.
I know.
So I'm gonna be so advanced. You ready?
Wait, it's advanced to have check your understanding where you
No, like you
practice
just
and
make out of ignorance. No, like why would you take your assignment?
because I want you to learn.
We're not learning from the test. We just get the answer wrong.
It's your choice.
Oh!
Let me tell you what I want to be a college.
When it's the first one down. I see the, how you got,
All right, so let's talk about it. Any conjectures that we came up with? I know Vicari says he has some ideas. What do you think?
Okay, so like, the way you got 2x minus 3, right?
I gave it to you.
Right. So the F third would be, you got 2x minus 3, we're doing 2 times x, and that was
That's not
2x.
the question that's being asked. Huh?
So what's that being added? Yeah, I showed on right now, not right now.
Vicari,
Wait, I see we got the.
that's, no, you're missing the question. The function h of x is constructed by taking this function, so we're taking the line y equals 2x minus 3, and we're dilating it by x plus 2. What do we know about h of x? H of x is the 2x minus 3, and we're dilating it by x plus 2. The question is, what do you know about h of x?
Is active form
Well, factor form of a what?
2x minus 3. Because think about it.
Okay, so a quadratic maybe?
Yes.
Why do you say no?
So it you asked for like.
No, it doesn't look, okay, so I'm glad I asked this question. This tells me what I need to talk about before we go to lunch to set us up right. So we're about to go back to that Desmos activity. That's part 2, that's not what I want. I want part 1. Okay. So right here, this is where we got to last week, and I need us to pay attention to this. So, I want y'all to remember that I have these two lines here, right? F of x equals, Amaya, can you hit the lights for me, please? We got this function here, f of x equals ax plus b. We got g of x equals cx plus d. And those are what type of functions?
Linear.
Those are linear, right? We all go with those are linear functions? Okay? And notice what's happening up here to get this h of x. I'm starting with what?
Zero.
Starting with f of x and doing what to f of x?
Multiply.
What's another way to say multiplying though? Dilating, right? I'm dilating or multiplying it by g of x. So I'm taking one linear and I'm multiplying it by another linear. And what do I get?
Well, you kind of, my mind is circling now.
I got a parabola. Okay, we need to make sure that we don't forget over the weekend the things we talked about. Listen, I have this red function right here is a what?
Linear.
Okay, the purple is a
Linear.
linear. And then up here to get h of x, I started with f of x and I multiplied or dilated by g of x, right? Okay. And what do I get when I multiply those two linear functions together? I got a parabola. What type of function is that? Okay, so when I take a linear times a linear, when I dilate it by a linear, I'm going to get a quadratic, okay? But there's something else we talked about with this, and I need to pay attention right here. When I look at this, isn't this going to be a quadratic? One, that's the factor form of a quadratic. Two, I want us to remember and think about this right here. What points does that quadratic always share with its factors? The roots. Right?
Yes, I see it. Wait, it don't do
So
like.
notice how this x-intercept is the same for the parabola and for the line. Bakari, hold on. When I look here at that purple g of x, when I look at that purple g of x, doesn't that parabola share the x-intercept with the line?
Yes.
Okay? So my question that I was asking here is, and this is what we really ended on, is if I take 2x minus 3 and I dilate it by x plus 2, what points do I know h of x will have to have? Well, it's going to have the same zeros. It would have to have this x-intercept and this x-intercept. Really, from there, we just have to figure out the positives and negatives, the concave up and down. Well, you get to go to lunch.
I'm saying about
We get to come back and finish this after lunch.
Do Desmos?
In just a second.
Okay.
Okay, so what we left off on, remember, was this idea that when I have, what component of the quadratic function is connected to the two factors?
You said that
Say it
again?
again. The zeros, right?
You said that again?
I asked, hey, ladies, I asked what features of the factors, the lines, can you open the door for Mr. So the zeros for the factors are connected to the zeros of the parabola, right? Wherever the parabola, or sorry, wherever the line has a zero, that's where the parabola has a zero. Okay?
But if the line's a zero, that's the parabola has a zero? Okay.
Keep going. Do you see how?
I know 0, 2, 0, negative 2.
No. Right here. That's an x-intercept, right?
Yeah, because it's on x-intercept.
Well, it's on the x-axis. But my point is,
Exactly.
you see how the line has an x-intercept there?
Come on, that right there, that line right there?
Yeah, the only line that goes through there, yes.
Linear line.
It's just a line, it's linear. You see how it also has, the parabola has a zero right there?
What zero? What parabola has a zero right there?
Okay, Bakari, I need you to remember, x-intercepts, what are they also called?
Zeros.
Zeros. Because the output is zero.
Zero.
R1, comma, 0. So, the parabola and the line both have an x-intercept right there.
Right, because they cross x-intercept.
At the same spot, yep. Yeah, same thing with this line.
Yes, I know that somebody just. I didn't shut down.
Okay, so they share those zeros, and it doesn't matter what the linear function is, however I change it, they always share those zeros. The idea was that I'm dilating or multiplying these. And so what I left with, nope, not that one. No.
Don't the lines cross,
Say again.
don't the lines to the linear line intersect?
They could, they don't always though. When would they not?
When were they not, when they
perpendicular.
Not perpendicular, close.
parallel, yeah.
Parallel.
Parallel.
Okay, so what we're trying to do right now is we recognize that this polynomial, this quadratic, will have these same zeros, but what we need to know is that parabola going to be concave up or down? When is the function going to have positive values? When's it going to have negative values? So what I will point out, and I'll remind you of before we go back to the Desmos activity, is just looking right here, this line, does it have positive or negative values right here?
Negative.
Why negative?
Because of negative 2, like,
Yep.
It has what?
It's on negative.
negative 2.
Well, be careful.
Oh, you
When we say values, which values are we talking about?
The numbers. I mean, the output.
Outputs. So the x is negative, right? But more importantly, remember how we called this x-intercept also a root or a zero? Yo, keep your feet to yourself. Like, holy crap.
me.
You're kicking each other. Keep your feet to yourselves. So that's called a zero, and if we're below zero, what is the value?
negative.
So we're below zero here.
I don't like this.
When I look above,
Positive.
those values are
Positive.
positive. And that's a key idea of what we're about to look at in the Desmos activity. Those positives and negatives inform us of our functions. So yes, I need you to go to student.desmos.com. You should, if you log in, you should already be automatically able to get in. So student.desmos.com, and one person per group have that pulled up. Everybody, there's one person in each group, right? Chris, you're getting it out for your group while Maddie's texting on her watch? Thanks. Doesn't even realize. Alright, Jamie's got it for her group. Tyler, you got it for your group.
Hey, it said, the code is in
Have you not used that code yet? There you go. Okay. So remember, if you've already used this code, it's right there. So if you've already signed in and you just scroll down, you can open it right from there. Huh?
They're trying to get me to make a account.
Well, do you not have an account yet?
No.
Okay. Well, someone in the group needs to have the iPad with an account, all those fun things. So, where we ended with Mr. Hobby on Friday. So, this is actually what we just recapped. What points?
Can you please have Taj dig into the office?
He's on his way.
Thank you.
So what points did f of x and g of x, the lines?
D-I-G, boy. D-I-K.
It's okay. What points did the lines always share with h of x, the parabola? They always share the what? The zeros, also called the root x intercepts, or the roots, right? So they always share those x-intercepts, those zeros. And so I think Mr. Hobby had someone come up, or someone volunteered, and we said, hey, if we're going to multiply the red and the blue function here, Makaria, can you give us one of the points that we know we would have if we multiply the red and the blue right here?
We on slide 5, right?
Listen,
If that's slide 5, yeah.
That's it, so.
listen.
Slide 6.
Okay.
Makaria, you not sure? Mel?
I might be tripping. I'm not really-
Yeah, I'm still.
Why? You know what happens when you get stuff wrong?
Learn.
You learn. Okay, so stop being scared. I'm just asking, if I were to multiply this f of x and this g of x to get h of x, so f of x, g of x, and if I were to multiply those two things together to get h of x, what point do we know h of x would have?
That was.
Was thank you.
If this wrong, I'm getting out.
Oh my gosh.
Yeah, like I promise, if it's wrong, I'm getting up the whole game.
Okay. So what do y'all think? We'll have that point.
What about the point on the line?
They're finna boot me off the
I got
stage.
one. This guy got the one?
Okay, Vigar, you want a different point?
No, sir.
Okay, let's see.
How many points do you want me to do? Just one?
Just one.
Okay.
Okay, so Vicari thinks that h of x would have that point. Anybody want to add on to or push back, identify a different point maybe? Huh? Thank you. Let's do it. There you go. Okay, what do y'all think about that point? That's what Addison was thinking?
It's on the x-intercept.
That's what you were thinking? That's the what?
It's on the x-intercept.
Oh, that is an x-intercept, isn't it?
So yes.
So, didn't we just explore and talk about how the parabola has the same x-intercepts as the linear factors?
Yes, sir.
So is that the only point that h of x would have?
Oh no, it's on one more on the.
It would also be the one over here as well?
Yes, sir.
Okay. So, we don't know about this yet. That's what we're about to explore. But, what I want to remind you and I want to point out is this. This function could look like this, like the blue, right? Or it could look like this. We don't know which one it is yet, do we?
No.
No, that's okay. That's what we're about to explore. What I do want to point out, and I want us to think about, because it's going to help us in a second, is when I look over here, would these values be positive or negative?
Both. I mean, both. 'Cause like.
Positive on the y. And when I say values, I mean the outputs. So the outputs are positive here. What about in here, in between these x-intercepts? Those are, they're below the x-axis, so these would be negative outputs. And then over here, this would be positive outputs. You'll notice I'm not focused on concavity right now. And I'm not going to focus on concavity when it comes to polynomials as a whole. Concavity is great for quadratics, knowing if it's concave up or concave down. But when I go into polynomials, a bigger group of polynomials, I need to be thinking about these positives and negatives. And that's what's going to inform us what these graphs look like. So this is where you ended on Friday with Mr. Hobby, was playing around with this. And I'm going to be a little bit more explicit. Mr. Hobby and I talked about it after the third block, and it worked well with my fourth block. So what we're doing is, you'll notice there's 2 points right here that I've already identified. And I want to make it clear that when I look to the left of this x-intercept, notice how I marked this x-intercept with a vertical dashed line. It moves around when you move your line, but I marked this x-intercept. And I'm looking to the left of that x-intercept. When I look to the left of this x-intercept, what type of values does this parabola have? Okay. And what we want you to be thinking about, one is, does it always stay positive? And two, remember, this is coming from that h of x is doing what with f of x and g of x? Multiplying them. Next, I want us to remember, what are we multiplying from f of x and g of x? What does this stand for? Isn't that the outputs of f of x, and this is the... I was like, that's g of x. Isn't that still an output? Just for the function g? So what I'm doing is, I'm multiplying the outputs of f of x and g of x. I'm multiplying those two outputs. So think about that. Think about the point I gave you. So how does multiplying these outputs tell me that these values are positive? And check to see if it holds in different places. So you're on slide 7 right now. What I want you to do with your small group is play around that slide 7, see if it always holds that to the left of this x-intercept, those values are positive. And if so, why are they positive? Because they may be positive right now, but they're not always going to be.
You said a little too quick. You said, please. You said you want me to turn if it's positive, right?
I want you to figure out if these outputs are always going to be positive.
Okay.
And how do the factors help explain if yes, or if so, why? And if not, why not? Okay, so we're using our factors to think about this. So let's get up, let's play around with those sliders, let's see what we can come up with for, yes, write your conjectures on the board. Some of us talking about B and D, but what did I say we were supposed to be examining and thinking about? The what? Yeah, something with the 2 points. We're looking to the left of the 0.
See this stay positive or negative?
What? You
And
say
why not?
it.
And why not?
What? But what is it?
If it's positive.
It's not the whole point.
It's concave up.
I mean, I see it's concave up, but that's not what I asked about. See, we're forgetting what I'm asking about. Is it still marked up there? No, we erased it. Chelsea, what did you write about over there?
Multiplying by negative outputs.
So pause just right there really quickly. What was it all about? The outputs. Well, we're going to come back to that in a second, but I want y'all to remember, when I look right here, when I left, I pointed out, I reminded you, wow, that is hideous. Please don't judge that. All right, when we looked right here, what did we say? We said these outputs are what?
Positive.
So why are we not talking about outputs?
Well, see, more.
So, what I want y'all to remember is, I know sometimes we get lost, I know sometimes we struggle, but I need you to engage in the things I asked you to engage in, because if we were focusing on outputs, this would make a lot more sense. Okay? Now, I want y'all to look at what Chelsea wrote, because she and I talked about this, and I want us to examine and look for this moving forward, but Chelsea wrote multiplying negative by negative outputs and a positive output. So, first off, where is she getting negatives from? We just said that was positive. Where is she getting negative outputs from?
The Y.
From the what? From the Y?
Yeah.
What Y? So remember, we're only looking to the left of this vertical line, right? Looking to the left of this x-intercept. Where does anyone see any negative outputs? Cameron,
2 negative
The climax.
the what?
2 negative.
2 negative 1, right here. 2 negative 1, which part of that, or negative 2 negative 1, which part of that is my output?
1.
The negative 1?
Yeah.
Remember, output is my
Negative
y. There's a reason why I identified those 2 points, right? That's a negative 1 right there.
Negative 2.
Negative 2, negative 4, and which part's my output? Negative 4. Okay, so remember, I'm taking the output of f of x and multiplying it by the output of g of x, right?
Yeah.
And what's negative 1 times negative 4? By the way, can you hit the light for me really quick?
4.
Negative 1 times negative 4 is what?
4.
Okay. So, let's look at this parabola. So at negative 2, there's my output. What is that output? It's what?
4.
Oh. Negative 1 times negative 4 is 4. The same as this output. Because literally, what's happening to get h of x? We are multiplying the outputs. That's it. Let's move this line a little bit more. We're going to make this easier in a second so you don't have to do quite that much. Where did my cursor go? Okay. That's cute. Okay. So once again, what are we doing? We are multiplying the what?
The output,
Okay, so what's my output here?
-2,
What's this output?
-4.5.
Okay, what is negative 2 times negative 4.5? Negative 2
Then calculator.
times negative 4.5.
I'm gonna guess 8.5.
We got calculators all around the room, guys.
No.
Negative 2 times negative 4.5.
9.
9?
Negative 9.
A
9.
negative times a negative is a...
Positive.
So it's positive. So we get negative 9.
What is that output, guys?
9.
That seems to be all it is. What are we doing? To get this parabola right here, we're multiplying the outputs, right? Now, I'm going to make this a little bit easier for you because I want y'all to recognize I don't have to do this point by point. Because I don't want you to do this point by point. I just want us sketching these functions. So let's look at this really quickly. To the left of this 0, I got a 0 here. To the left of this 0, all of these y values are what?
Negative.
So all of my outputs are negative. What are all of these outputs? And tell me this, what do I get when I take a negative and multiply by a negative?
Positive.
And what are all of these outputs?
Positive.
Oh. That's why all of these outputs are positive. Notice I'm not focusing on concave up and concave down because that works well for quadratics, but we're starting with quadratics and we're going to go beyond quadratics. Okay? So, I would just make a note to the left of this 0, a negative times a negative is a positive. I know everything to the left of that 0 is going to be
Negative.
So basically all we gotta do.
of h of x is going to be positive. Say again, Bakari?
Whoopsie daisy.
So it makes kind of more sense now.
Yep.
Everything that you
By the way, for those of us who are stuck, did we move to the second slide and read these questions? Because what does the first question say? What do the vertical lines mark for each function? What is this vertical line marking?
the outputs and then
This vertical line.
the output
The y-intercept.
Close.
the 0.
0.
I was saying, these vertical lines are marking the zeros, also called x-intercepts. Notice I'm focusing on the x-intercepts. Describe how the output values of the linear factors explain the outputs of h of x. Notice, guys, if y'all had gone to the next slide and looked at those outputs, or that detail about outputs, I've tried to set this up. Guys, if you're stuck, that's okay. Come up with something. Go to the next slide. You just have to have conjectures. Go to the next slide and use that to help drive your thinking. Now, we need to get to slide 9. What does slide 9 ask about?
The different
Example.
see that?
By examining the values of h and x in between the vertical dashed line, refine your conjecture of about how the values of H and X are linked to the linear factors.
So notice I'm now looking in between the x-intercepts, right? In between the vertical dashed lines. In this case, what kind of values does this parabola have?
Negative.
Okay,
Negative.
those are negative outputs. Go to your groups, talk with each other, and let's come up with a conjecture about why those are negatives. Play around with it. See if it keeps holding. Let's get up, let's get moving. Come on, can you hit the lights for me, please? I don't think y'all got in trouble, did y'all?
I started
It was
recording.
just like spring practice, but in the fall.
You could've did it.
Anyways, right here. So, I need us to look at this. Now, I want us to pay attention to this. When I look here, we can move this parabola no matter where we move it, or the linear factors, because that's what we're really doing. No matter what, the parabola had what kind of values?
Negative.
It had negative values, right? In between those two x-intercepts, the negative values. And so I see a group here saying, because it's passing through the linear factors. Actually, that's a pretty good note, right? When I look here, all of these values were what?
Positive.
Positive, and then it had to move through the linear factor. So it went from positive to being negative, right? Now,
Alright.
that's not always going to be the case, so I need us to pay attention to this. So listen, passing through, great. But it's not always going to operate exactly like that. By the way, I had that box on the ground because I needed it to be taken out, so if you could get it off the trash can so people can use the trash can. So here's what I want us to remember, right? Now, right here, for slide, is this supposed to say for slide 9? So what y'all are saying is both lines are negative. When you say the lines are negative, what do you mean the lines are negative? They're going down?
It's at the bottom.
That's going down?
It's going up.
It's going up, like a mountain.
Mountains don't
So,
go up.
be
It's already
careful.
up.
So
Nobody
remember,
asked you, right?
y'all, I need us to pay attention here. Right here. There's a difference between the slope and what we're talking about. So first off, slope-wise, the slope is what? Both those lines, the slope is positive.
Good job.
So both lines are increasing because the slope is positive. Hey, Kamaya. Instead of writing your handle up there, can you please engage in this learning
I hear
process?
you.
But I need you
I'll
looking.
be complaining about y'all, no?
That's your account name.
Oh.
It's called a handle. No, that's what it is. I'm sorry that you did not, I'm sorry that you didn't learn it.
Username.
Be complaining about y'all,
I
no?
know, I'm sorry that you didn't learn what it's actually called, but it's called a handle. It's always been called a handle?
It's called a username.
Okay.
Okay.
So, right here, slope is positive, sure, but remember, this wasn't about the slope, it was about the what?
The value.
The output.
The outputs.
Okay. I gotta remember the outputs is the y-axis, right?
Y values.
The y
So
value.
remember, these outputs were what? What kind of outputs were right here?
Negative 1.
These outputs
I
were,
mean, negative.
and what was a negative
Positive.
times a negative?
I mean, positive.
Oh, and all these values were?
Positive.
Okay.
Positive times a positive.
But
It's a positive.
first off, a positive times a positive is still positive.
Negative.
Second off,
Brain cells.
these values are what? Hey guys, these factors, those values are positive. Down here, notice I said down, those are,
Yeah, that's the positive times a positive.
no dog, those are negative. The
Yeah, because
outputs,
the positive times positive.
no, those are the factors. And what is a positive times a negative?
Negative.
Oh, and what type of values does h of x have? Hey,
I was right.
what are y'all doing? We got 5 minutes left. Don't even attempt to pack up.
Are you
Turn
outside?
around and run over here.
You must be
I was gonna
outside.
buy you.
Tell them. Alright, look. Guys,
Come on, you know what you're doing? You know this?
excuse me. Hey,
I'm sorry, I'll leave it alone.
I just need us to recognize that we're talking about a set of positive values being multiplied by a set of negative values. And what's a positive times a negative?
A positive.
A positive.
Positive times a negative is a
Positive.
negative. You take a positive 3 and you multiply it by a negative 2, you get a negative 6.
Negative.
Positive times a negative is...
Positive. A negative.
Stop trying to screw people up.
I'm trying to screw me right there.
Alright. Hey guys, I just want us to think about this and predict this right here. So why in the world are these values positive?
Because they go up.
They're above the
The
x-axis.
Well, I mean, I know they're positive because it's above, but what I'm asking is why are they positive?
Because of the value.
Because it's above the X.
Yeah, he trying to steal my phone.
I've had
Hey, guys, listen,
That is dead center.
right here. You are completely departing from everything we just talked about. Why were these positive? Because a negative times a negative is positive. Why were these negative? Positive times a negative is negative. So why are these positive?
Because a positive times a negative is positive.
Negative times a negative is a positive. Yeah, times a negative is a negative.
Hey,
A positive.
pause.
It's real stuff. Look up.
Hey,
Trying to help
nice.
you.
Caden, y'all are forgetting that the fundamental piece of this is we are literally taking
Are you in the camera, bro?
the outputs of f of x and doing what with them? Multiplying them by the outputs of c of x. So stop skipping looking at the outputs.
Yeah.
What are these outputs for this factor?
Positive.
What are these outputs?
Positive.
And what's a positive times
Negative.
a positive?
Negative.
Listen, I'm gonna drop kick you. I know you think you're funny,
Start sweating.
but stop trying to screw up my students. So, listen, it's all about multiplying the outputs. That's it.
I just got 13.
A negative times negative is positive. Positive times negative is negative.
I'm going to
We're
the
gonna
police.
continue working with this tomorrow. Okay.
I'm going to the police. I just got 13 get dropped in the bagger on that. That is, what is it? Something with deadly weapon from Mr. Kenny.
Good job, Mr. Kenny.
About what?
Got that all day. Hey, John, go grab my phone.
Hey guys, if I were you, I would at least take a picture of this.
Recording, get the camera.
Yeah, most of them are not going to get on YouTube. Kaden, you take a picture of this note yet? Jaquel, Tyler, Zakaria,
Hey, y'all need this.
take a picture of this
Bakari.
note yet?
I'm trying to get this in the photo.
Guys,
We're doing
this is a
Addison, move your head.
foundational piece.
Come on, hold on.
This is a
No, I was trying to get. Bro, get out the photo,
You
bro.
can also walk over your head. Look, this is foundational that you cannot forget, and this is why y'all are struggling. We're multiplying the outputs of those functions. You cannot forget that it's all about multiplying by the outputs.
We done. We done.
I wish I was kidding.
Mr. Kenny.
Thank you.
We're gonna get everything in.
Yeah, that's
Excuse me, Master. I ain't trying to get you in the photo. I was trying to make sure we were getting everything.